Hi, this is John V6EY with an update on my software development project. I'm designing a program that will be able to control diversity receivers and save dual channels of IQ data to disk so that they remain synchronized, and I can use recordings later on to play with diversity reception instead of just being able to do it live. So it's been coming along, and I ran into a problem a few weeks ago where my test program was using way too much CPU cycles. It was running 70–80% of my CPU doing its decoding, and that's just nowhere near good enough for what I'm trying to do. So I went back and I redesigned the entire program to work with a pipeline. And what I'm doing is all of the DSP work is done in background threads, which are separate processes that run on the computer. And they enable you to maintain the use of the user interface. It doesn't sort of slow down while all the DSP work is being done. So that's one thing I did. And what I'm showing on the screen here is a picture of what the pipeline is. It's 3 threads, worker A, B, and C, that run sequentially, and the first thread takes the data from the radio and also does the recording. The second thread, worker B, does the decimation, filtering, and demodulation, all the heavy work for the DSP. And the final thread, worker C, produces the audio and also crunches numbers for the on-screen display. And that's the idea of a pipeline. You just get a bunch of data from the receiver and you put it through these 3 steps in the pipeline, and out the other end comes your finished product. Part of my objective here was to build a flexible pipeline that could work with almost any receiver, and also would be optimized to reduce the amount of CPU power that was being taken. So I went back, I redid my code from scratch, and I'm going to give you a demonstration now of how that looks. Here's my test bed. I'm going to get it started. It's the same idea, controlling the Perseus and running it through my pipeline.
The victim has been identified as 35.
So there it is working now. What I want you to do is look at these 3 numbers. These are the durations that are spent by each worker thread, A, B, and C. And the amount of time is in milliseconds. So you can see thread A is using less than 1 millisecond, thread B less than 1 millisecond, and thread C right now is only using about 30 microseconds. And this is running on a pretty ordinary i5, nothing special about my computer. So if I add these up, I'm taking around 3 milliseconds to do all the processing of the data that's coming through. And since each chunk of data is roughly 40 milliseconds apart, there's lots of time to get the work done and be ready for the next buffer of data to arrive from the receiver. So why am I showing this? Well, when you're writing software, knowing what you're doing really helps. I was able to go back and find all the mistakes I was making. I was able to build a pipeline using some ideas I found in a few books. And I'll describe the whole thing in more detail on my website, Making It Up. This is John V6EY.